Welcome to SOLIDWORKS for the Engineering Design Process, Lesson 2, Section 3. In this section you'll learn about subassemblies and the advantages of using them. You'll see the difference between an assembly composed of many parts and one composed of subassemblies. Components from the windmill assembly will be used to illustrate these concepts. This windmill contains a component called a dynamo, which is essentially a generator. This dynamo contains 8 different parts. You can organize these parts by making a subassembly, which is simply a collection of parts. In the first portion of this lesson, you'll create a subassembly for the rotor component, and then bring together more parts to build a well-structured dynamo assembly. As discussed earlier, you'll first build the rotor subassembly of the dynamo. Click New and select Assembly. Pin down the Property Manager and click Browse to add the 4 parts that will make up this subassembly. These are the dynamo rod, the dynamo magnet, the dynamo gear, and the mantle rotor magnet. Once the parts have been added, click the green check mark. In the previous sections, you created an assembly by mating parts together. A subassembly is created exactly the same way. Begin by creating a concentric mate between this part and the rod. Click the green check mark to apply the mate. Next, create a distance mate between the 2 front faces and set the distance to 30 millimeters. Click the green check mark to apply the changes. Notice the 2 components can still rotate relative to each other. To lock them together, you need to create a coincident mate between the right planes of each part. Expand the Feature Manager design tree, then expand the 2 parts and select the right plane for both. And select Coincident. Now the 2 parts will not rotate relative to each other. Next, create a concentric mate between the magnet and the rod. Then, create a coincident mate between the front face of the magnet and the back face of this part. Similar to the previous step, create a coincident mate between the right plane of the rod and the right plane of the magnet. The last part that requires mating is this shell. Create a concentric mate between the shell and the rod. Since the shell is facing the wrong direction, click Flip Mate Alignment to correct its orientation. Next, create a coincident mate between this small edge on the gear and the front face of the shell. Again, create a coincident mate between the right plane of the rod and the right plane of the shell. Now you've created a subassembly for the rotor. Save it as Windmill Dynamo Rotor, and you are ready to use this in the dynamo assembly. Since the dynamo is just another assembly within the windmill assembly, it is also technically a subassembly. So you will now use the rotor subassembly to build the dynamo subassembly. Start a new assembly. Pin down the property manager and add the dynamo housing, the dynamo inside housing, motor cap, and M4 screw from the provided parts, as well as the rotor subassembly you just created. To do this, ensure that you select all files at the bottom of the open window. Begin by creating a concentric mate between the circular surfaces of the inner housing and the rotor subassembly. Now create a coincident mate between the top face of the inner housing and the inner surface of the rotor subassembly. Create another concentric mate, this time between the rear cover and the housing. Make one more concentric mate between the rotor subassembly and the housing. Next, create a coincident mate between the front face of the rotor gear and this inner surface of the housing. Finally, create a coincident mate between the outer rear face of the housing and the rear cover. Make sure the gears line up at the rear by adding a coincident mate. The only thing left to do is to place the screw. Create a coincident mate between these two circular surfaces and a coincident mate between the surface of the rear cover and the inner surface of the screw. Lastly, add a coincident mate between a plane of the screw and a plane of the housing. This subassembly is now complete. Save it as Dynamo Subassembly. In this video, you learned about how to make a subassembly and insert it into an existing assembly. You also learned about the advantages of using good assembly structure and its relevance to the engineering design process.